There we go. Our lesson today is on writing probability as a fraction. Now we know that fractions have a top number and a bottom number, which are the what? What do we call that top and the no? What do we call the top and the numerator and the denominator? That's right. Well, as we make probability into fractions, we know that the top number, the numerator, is the number of events they're asking us about. The bottom number is, just like in a real fraction, our total, all the possible outcomes that there could be. What is the probability of an event? So this guy here, his name is Ruben, and he puts each letter of his name on a sticky note and he throws them in a bag. Okay? Now, he's going to pick one piece of paper out of this bag without looking. The probability of an event is a number that describes the chance that that event is going to happen. So how many letters are there in this bag? There's 6, okay? So 6 things could happen. His name contains 6 letters. The probability is the number of favorable outcomes compared to the total number of possible outcomes. So could probability be actually bigger than 1? Yes. Well, let's think about this now. What if, the bottom number is going to be 6, right? I just feel like this is moving. Because there's 6 possible pieces of paper. Could this top number be 7 or 9 or 10? Well, because if it were, that means it would be more than 1. The biggest amount would be 6 out of 6, right? Which is 1. What's the probability that this kid is going to choose a letter B? Lingen? 1 out of 6, or we can call that 1/6. Think about how many favorable outcomes there are for B's. There's only 1, and there's 6 possible. So 1 favorable out of 6 possible. What does something mean if it's equally likely? Well? If something's equal. No, not most likely. Most likely and equally likely are quite different, actually. Tell me something in this bag that would be equally likely to happen. America? The letter E and the letter what? It's equally likely to pick the letter E as it is the letter... I think you're heading down the wrong path, my friend. We want 2 letters that are equally likely. What do you think, Sam? R and U. There's 1 R and there's 1 U. Why don't we want to use the letter E? Because there's 2 of them. That's right. Now, if we talk about what's the probability of choosing a letter, the letter B, we make a P, and it's kind of a tilted P. We call this probability. What's the probability of drawing a letter B? Okay, what about the probability of drawing a letter E? Cole? Okay, which is also 1/3. Good work. Good work. We can certainly simplify 2/6 to make it 1/3. The chance of choosing the letter E is greater because there are 2 E's in the bag, more than all the other letters. Here is a spinner. Tell me the probability of spinning a blue. Brendan? Out of 2 out of 8. Another way we could say that is what, Emma? 1/4. So you're right. 2 blue out of 8 total is the same as 1/4. How about the probability of spinning a yellow in this spinner? Alexis? 3 out of 8. Now I'm going to ask you a different question. What would be the probability of not spinning a yellow? Aiden? 5 out of 8. That's right. Now, you counted them up. I watched you nod your head as you were counting around. But what would have been a quicker way to do that? Minus the yellows. We know there's 8 total. Take the yellows away, and we're left with the remaining. What about the probability of spinning a red in this spinner? Natasha? 1/8. The probability of spinning a green? Alan? Okay, we can call that 0 out of 8, or we can use a word. The word is called impossible. Does that make sense? Impossible. What else is impossible in this spinner? What else? Aiden? A pink. Spinning a pink would be considered impossible. Now, I'm going to ask you this. Out of all the colors on this spinner, which color is most likely to be spun? Eileen?
Yellow.
Why yellow?
Because there's 3 of them and there's
That's right. There's 3 of them, more than any other color. Okay, so we're going to take a look here at some practice questions, and then we are going to create our own. Okay, so Mrs. Horry made a spinner with the first initials of 3 different animals that they're going to study in class this week. What's the probability that this spinner will land on a T? Put your pen down. Kaylin? Say it again. 1/3. A bag has buttons inside. There's 5 red, 3 blue, 7 purple, 15 white. But you can't see inside the bag when you reach. You're going to get 1 button. What's the probability that Marcus will reach into the bag and pick a white button? Aaron L. Tell me how you got that. Okay, so we know our bottom number's 30, right? Our bottom number's 30 then. That's our total. Good work. Exactly. Nice job. Probably a good idea to add those twice to make sure you get the same number both times. Katie and 5 friends are forming a club. Darius, Alexis, Darius, Alexis. Katie and 5 friends are forming a club. Now each club puts their name on a piece of paper and puts it in a bag. And they're going to draw one name from the bag to be the president. What's the probability that Katie's going to be the president? Guess who I called on in my room for this question? Cole?
1/6.
Why did you pick 6? Because it says she has 5 friends. Katie and 5 friends. So you're right. It is 1/6. Good job. Andy's going to spin this spinner. What are the chances it'll stop on a red? I know it's hard for some of you to see this. Sarah?
8.
Okay. How did you know that?
Because I looked at the red ones and it was 4, and then I looked on one side how many were on that side, and then I just doubled that, and then it was 4/8, and then that.
4/8 is the same as 1/2. Good work. Now, this one's a little trickier, and we're going to go through all these together. Which of the following would not be fair? So I'm going to read it. You tell me fair or not fair. Ready? Toss a penny. If the penny lands heads up, player A wins. If it lands tails up, then player B wins. Fair or not fair? Fair. Okay. Next one. Roll a number cube. If the number's odd, player A wins. If the number's even, player B wins.
Not fair.
Why not? Why is that not fair? How many odds are there? How many odds are there? How many evens are there? Okay, then it's fair, right? Well, that's okay. That's how we learn. Take a spinner. The spinner has 4 equal areas. 2 of them are shaded, 2 of them are not. If the arrow stops on a shaded area, player A wins. If it stops on an unshaded area, player B wins. Well, let's see what we got here. Well, hopefully it's D, otherwise we made a mistake. Choose a letter from the alphabet. Here's where we are, Alexis. Right here. If the letter's a vowel, player A wins. If the letter's a consonant, player B wins. Why? Aiden, why isn't that fair?
Because there's more consonants than vowels.
You're right. You are right, buddy. Okay, so I want you to open up your iPad to a blank screen. There may be one in the card. I don't know. You just have to remember to put those back for me, okay, guys? Okay. On your iPad blank screen, it is going to be your job to look up at my full name. And I want you to give me two answers. I want the probability of drawing a vowel if I put every letter on a sticky note and put it in a bag, and the probability of consonants. Here we go. Must be simplified. I need the probability of vowels and the probability of consonants. Who wants to share their fractional probability of vowels drawn? I think you're off a little bit, Alan. I think you need to rethink that. I want the original so that if you simplify, that's fine, but then I need to see both of those two next to each other because I think that you counted wrong. Cole? 6/14. And instead of counting up the consonants, that makes the consonants to be how many? 8/14. Who can simplify 6/14 for me? Natasha? Natasha says this would be 3/7. And down here, this would be 4/7. Put your thumb in the air if you got this right. Now, where did we have trouble? Did you guys count wrong? 6 letters, 3 letters, 5 letters. 14. You know your bottom number then is our total. That's 14. You guys know that vowels are A, E, I, O, U? Today, we're not going to count Y as a vowel, and I don't have any anyway. All right, now, it is your job. I want you to write your full name. First, middle, last. I want you to find your own fractional probability of vowels and consonants.